I'm Living Dong, and on behalf of all the co-authors at Nanjing University Top-of-Class Research Laboratory, I'm presenting the survey on pains and the best practice of code review. You can find out more about our lab by visiting our website. As part of the software development process, quality assurance is becoming increasingly important. A code review process, which seeks to identify violations and alternatives, has become one of the most important methods for ensuring quality and transforming knowledge. To ensure code quality, reviewers conduct code reviews as part of their daily routine. In the past few years, many software enterprises, such as Google, Microsoft, have shared their experience with code reviews. Those are examples of best practices. However, little is known about the best practices employed by other small and medium-sized software enterprises. Compared to previous code inspections, code review today is more frequent, lightweight, and less formal in industrial and open source contexts. Thus, code review is strongly influenced by developers' understanding, expertise, and engagement. And that is a humble recognition of the quality of modern code review. The best practices have been generally valued and are now commonly accepted as a good way to perform code reviews. Observing our collaborators, we discovered that there is a lack of awareness of best practices in small and middle-sized software projects. Engineers do not know the best practices associated with their work. In addition, even the public annual report concludes best practices, but those best practices are not extracted from the frontline production team. Those best practices abstracted at a high level, which make them hard to guide the specific activities such as code review. Therefore, our research complements this review, but not only extracting best practice from industry communities published in great literature, but also from the academic papers. By conducting this study, we intend to provide practitioners and researchers with a better understanding of code review best practices, as well as the pain points that can be elevated by using best practices. More specifically, we have two research questions. The first one is what best practices are available for performing code reviews? And the second question, what pains associated with code reviews have been elevated by implementing best practices? Our research process consists of two parts, academic literature research and great literature research. We used both automated search and snowballing strategies to select the relevant publications. There are three phases in each part, planning, execution, and extraction and synthesis. During the planning phase, we aim to determine the optimal set of keywords for the search string. Each keyword can be organized with the flexible substitute word as shown here. For example, code review, peer review, best practices, recommended practices, pains, challenges, difficulties. To locate academic publication for our review, we search 5 popular digital libraries. A comprehensive collection of the literature on computer science and software engineering can be found within these popular libraries. Additionally, we analyze the Google search for retrieving great literature on code review best practices. Inclusion criteria and exclusion criteria are crucial to determine the quality of our publications in this review. However, they are difficult to determine because the diversity of publications at the beginning of this process. It is important to note that our inclusion criteria item 2 is the most important for us to conduct manual filtering after receiving the initial search research. This can ensure that the publications describe code review practices used in the reviewed projects or proposed by authors or enterprises. This figure details how we process and filter the publications we received from academic and degree literature. Our quality control process includes several stages. In particular, we filtered out publications that did not meet our selection criteria after removing duplicate and other research field papers. We conducted backward snowballing in the fourth stage. As a precaution, we also double-checked the primary study list of the 2 recent reviews in this year to ensure that we have not missed any relevant academic papers. Therefore, we ended up with a set of 20 peer-reviewed academic papers and 13 degree literature publications. From the bar chart, we state the increasing numbers of publications has been published in recent years. Since 2019, there has been a notable increase in total publications on code review best practices. Among them, degree literature accounts for nearly half of the recent publications. The 2 most common academic methods are survey and case study. To organize the search result for best practices and pain points, we followed the mainly 6-step code review process. According to this mind map, each branch has 3 parts. The first part is about code review process, and the second part is about the main goal of best practices, and the third step is about each detailed description of the best practices. As illustrated in this mind map, the main result of the first research question represents 57 best practices relevant to the code review process. Based on this graph, we can see that each step in code review has been supported by numerous best practices. For instance, step 3, when proving and conducting code review, they could use automatic tools before manually conducting code reviews and allow them to handle shallow errors and defects. And the reviewers should more pay attention to high-level concerns, such as the maintainability of source code. In practice, however, it is still difficult to know where to begin when introducing best practices into projects. In order to provide an entry point for selecting best practices, we also examine pains of code reviews that could be elevated by these best practices. Based on the bar chart, we can see the reviewers suffered from the pain of being unable to comprehend the combined code changes and the code context, which is the most serious question. For code authors, it is difficult to select appropriate reviewers. Some publications also facilitate us to map the best practices and pains of code reviews, indicating that multiple actionable practices are needed to eliminate code review pain at the same time. We discussed further our current findings and I learned that most of the best practices are difficult to guide developers to implement as they cannot be standardized. As a standard, reviewers are asked to follow generic best practices. But best practices rules did not explain how to do and give actionable implementation tips. In other words, they are not yet ready for practitioners to use. A few studies in our current datasets provide insight into automatic techniques, tools that can support best practices. In the future, we will plan to extend the research question to provide automatic techniques or tools that would be useful for implementing best practices and addressing the pains of code review. Engineers have a vague impression of best practices based on our investigation. Based on this question, we conducted a systematic review of academic and degree literature to gain a comprehensive understanding of the best practices and the challenges of code reviews. That's proven by real-world projects and organizations. By reviewing 20 peer-reviewed scientific publications as well as 13 grey literature sources on code review, we summarized 57 practices and 19 code review pains that they can address. In the future work, to enable the adoption of best practices, we plan to extract automatic techniques within code review tools to help practitioners to implement best practices rules and conduct code reviews more successfully. Here is the summary of the presentation, and I would like to thank you very much for watching.